Okay, hello everybody. We hopefully got enough practice on integration by parts that we're ready to move on to the next section. This is really the last section where we keep it feels like every section we unveil like a new strategy for how to integrate. We started with 3 basic formulas, and then we looked at how integrating by the U substitution allowed us to integrate some more complicated formulas. And then we were looking in this last week at integration by parts, which allowed us to integrate even more complicated integrals. And now we're going to end with what's called a table of formulas for integration. Okay, and this looks super intimidating. There's this whole list of formulas here, none of which you guys will need to memorize. Okay, but you can see there's formulas labeled all the way down to like formula number 23. The reason this starts at formula 9, and if you actually look at, I think maybe the back cover of your book, if you flip the inside of that, it has all these formulas listed. The first 8 are really all the other formulas that we've learned already. Okay, but what I want to draw your attention to right now is I want you to look. These are kind of clumped together in different boxes, and you can see along the left-hand side here, they sort of group these in categories. And you'll notice that where you see P's in these formulas, that's like our variable X. Okay, so all these places that you see these P's, those are just your variable, whatever it would be in the problem. Okay, now I think this is the first thing that we should definitely kind of take note of here, and that is whatever is on the left side of the equation. Okay, the left side is representing, or the left side represents the original problem. Okay, so when you're given an integration problem, you're going to look through this list of tables, and you're going to this list of formulas rather. You're going to try to pick out a formula number where you feel like the left side of the formula kind of matches the format of your original problem. Okay, the right side of the formula, okay, the right side is your answer. Okay, so at the beginning of these problems, you guys are really just looking at the left side of the formulas. Okay, and I'm just going to scroll on down through here. They do a really nice job of sort of grouping these by similar things that you would see on the left side of these formulas here. Okay, and so here's what your goal is. Your goal is going to be to choose a formula where you feel like the left side, okay, the left side of the formula matches what your integration problem is. And the problems we're going to look at today, I think it's going to be pretty easy for you to find which formula is going to match your integration problem. Okay, it will progressively get more difficult in later lessons, where if it feels like it's not a perfect match, we're going to learn how it can be made to match it, even if it doesn't look like it's an exact match at the beginning. Okay, so let's look at our first example. Okay, so I'm going to scroll to the next page here, and you can see we have an integration problem. Now, most of these problems are going to have X's in them. They're not going to have P's, but we're going to need to make some substitutions, okay? And so the very first thing that you are going to want to do is your first step is to decide which formula you're going to use, and you're going to identify that formula number and whatever formula it's going to be, and then you're going to write out that entire generic formula, okay? So here's a pointer that I can give you. As you look at the original problem, you want to try to pick out, okay, what's the most complicated aspect of that integral? And for this problem, it's easy. The denominator is definitely more complicated than the numerator. And you can see the format of the denominator is it's a variable squared minus a constant, okay? So as we go back and we look at our options on the front, Okay, and I'm going to actually draw your attention to really the left side here. I can automatically eliminate these first four formulas because remember, p is our variable. That p is not squared. Okay, nowhere in our problem did we have a square root symbol. Okay, so I can also, we said we were eliminating that. Oops. Nope, we said we were eliminating this first one here, but I'm going to eliminate our original problem. Like, it does not have a square root symbol, so we can get rid of that. Okay. Well, there's square root symbols down here, so it's not going to be any of these that have square root symbols in them. You'll notice these ones at the very bottom, they're reserved for specific things where there's an e in your integral or there are natural logs in them, which is obviously not that. So pretty quickly, you can get it narrowed down to at least one of these boxes pretty quickly, okay? Now you'll notice for formula 15 and formula 16, my options are either the denominator is a variable squared minus a constant. This a squared you see here, the a's are constants. A's, b's, c's in these formulas, those are all constants. The p is your variable. I'm going to write that down here off to the side. P is the variable. Okay, that's your variable. Okay, so let me just declutter this a little bit here. All right, so I think we got it narrowed down to this is definitely the box that we're going to be looking at. And let's scroll back and take one last look again at our problem. You'll notice the order that this came in. It had the variable squared first, then it was minus the constant. Okay, so when I scroll up and I'm looking at should I be using formula 15, should I be using formula 16, I would want to go with formula 15 because formula 15 has that variable squared first minus the constant. So what I'm going to write down is I'm going to go ahead and write down that I'm using formula number 15, and from the front I'm copying down formula number 15 exactly, oops, sorry, shoot, that's a P there, okay, exactly as it appears here. Okay, so this is going to be P squared minus A squared. Okay, I'm just copying this down exactly how it looks. Okay, now the next thing that we want to do is we need to decide what substitutions need to be made into the left side of this formula so that I can get the left side of the formula to match my original problem. I want these two things right here to match exactly. Okay, so here's what my options are. For sure, I need to replace the P with an X. Okay, if I'm wanting the left side of my formula to match the original problem. Okay, now anytime you're going to swap out a variable for another variable, you're going to need to take the derivative of P, which would be dp over dx, and derivative of x would be 1. So that means that when I make this substitution, okay, I'm going to make this substitution here, in place for the P, I'm going to put an X, and in place for the dx, I'm sorry, for the, yeah, oh, I wrote that wrong. This should be a dp right here. Okay, in place for the dp, I'm going to put a dx. Okay, now I have another substitution here. You'll notice there is an a squared right here. Okay, now I have to plug something in for the a so that after I square it, it's going to become a 4. Okay, so that means the a really should have been a 2. Okay, so that means I'm going to plug in a 2 squared, and probably in the next step I'll just change that to a 4. Okay, by the way, had the original integral been, let's say it was x squared minus 3, okay, then I would have chosen for a to be the square root of 3. That way when I plug it into the formula and I square a square root of 3, it would show it as a 3 there. Okay, Okay, so once I've established these are my substitutions, and I feel like the left side of my formula with those substitutions made into it matches the original problem. Okay, it has to match. If those look exactly the same, then I'm good to go with the right side. I can just make these substitutions here into the right side of the formula. Okay, so I'm going to plug X's in for the P's, 2's in for the A's. Okay, and if anything requires me to kind of multiply it together or clean it up, I would go ahead and do that. And here's what my answer is, which is technically just the right side of the formula. Okay. Okay, let's try one more here. Okay, we're going to take a look at this next problem. We're going to pick what is the most complicated aspect of this problem. It feels like maybe the denominator is a little bit more complicated than the numerator. By the way, when it says find the total sales, that is asking us to integrate. You can see this is a derivative, a rate here. So I'm going to go ahead and set this up like that. Okay. So then we're going to go to the front. Remember, we said the more complicated aspect is the denominator. And notice this has a square root symbol in it. Okay, so my variable x, it looks like a p when I look at it here, though. Okay, so I'm going to get rid of all this where I crossed all this stuff off before. Okay, I'm looking for something that has a square root symbol in it in the denominator. I don't want it to be a p squared. I just want it to be a p plus a constant. Okay, so let's see if I can find that. It's going to have a square root in the denominator. Well, it's not going to be that. There's no e's or natural logs. That doesn't have a square root in the denominator. That doesn't have a square root in the denominator. Those don't. Okay, so I'm looking through here. Okay, none of these even have square roots in them. So I need to pick something that doesn't have a p squared in it. So for that reason, I think I can eliminate those pretty well. I'm looking for just a p in the denominator under a square root. Pretty confident here that this looks like this is a pretty good match. Okay, you'll notice in the numerator there's also a p, and that's kind of what we have here. We had an x in the numerator here. So I'm going to go with formula number 13. I'm going to go ahead and write formula number 13 down. Okay, here's how formula number 13 looks. Whoops. Get rid of that. Okay, and the right side of formula 13, I'm just jotting this down here. Okay, now here's our goal. Our goal is to focus on the left side of the formula. We need to get it to match the original problem. Okay, and we're going to do this through substitutions. Okay, so I'm going to definitely swap out the p for the x, which means the dp comes out for a dx. Okay, I'm going to take a look and say, well, a is a constant. It's directly in front of the p. What number is directly in front of the x here? Well, it's just a 1, so a is a 1. And then b would just be the number 9. Those are just swapped right out there. Okay, and so to get my answer, I'm now going to make those substitutions on the left side of the formula as well as the right side here. So every p comes out with an x in its place. dp gets swapped out for dx. Okay, I'm going to make these substitutions here. Okay, and then just to, oh, sorry, that should have been an x. Ugh. Okay. Okay, now there would have been the answer. To finish this off, to evaluate the c, I should plug a 0 in on the left. I should plug a 0 in on the right. And the answer for this ends up being this. Okay, I'm sorry that I'm flying through this. I know I'm running out of time. I'm going to get cut off here. Okay.